Hello students, today we are going to start the first part of chapter number 8, motion. In this part, we will be discussing the following topics. First we will discuss motion, then distance and displacement, then scalar and vector quantities, then motion along a straight line, and then few practice questions to check your understanding. So watch the video till end. Now let us understand the first topic, that is motion. We have seen various objects around us that are moving. For example, bus, trains, humans, running and playing, even the celestial objects like sun, moon, and even the earth, even they keeps on moving in the solar system. So how we can say that an object is moving or not? For that, we need to understand the definition of motion. Let's see. It says that movement of any object from one position to another position with respect to a reference point is called motion. It means a body should change its position with respect to a reference point. Then that body is said to be in motion. Let us see an example. In this figure, we can see that on the roadside there is a house and a tree which are stationary. So this tree and house will act as a reference point while this car is moving. So at first instant it is at position A, and after 5 seconds it has changed its position and it has reached at point B. So we can say that if here the car has changed its position with respect to this reference point, that is the tree and house, so we can say that yes, the car is in motion. We can take similar examples for a boy running or playing, for a birds flying. So they all changes their position with respect to a reference point. The reference point can be anything. It can be any stationary objects like house or a tree or a building or a pole or even a person itself who is observing that object. Now let's see what does the position means. Now motion of any object is defined by its position with respect to the reference point. This we discussed just now. Now what is the position? Position is actually the location of the object. For example, if suppose you are uh, you are near to a school or a yeah, you are near to a school, and if someone asks you that where you are right now, then you may say that yeah, I am at 1 kilometer from this school. So this actually what you are giving your position with reference to a reference point, and here in this example the reference point is the school. So this is how the position is mentioned using the reference point. Okay, and if an object changes its position with passage of time, then it is said to be in motion. Okay, now what does this reference point means? So it is the point from which a location of object is measured, and it is often known as origin. And this reference point can be anything in different contexts. It can be school, it can be tree, or it can be anything. Okay, so this was about the motion. Now let's move to the next topic, that is distance and displacement. Now what is distance? Distance is the actual path traveled by an object from its initial position to final position, and it is a scalar quantity. We will discuss what is scalar quantity in the later in the video. And what is displacement? It is the shortest straight line between the initial and final position. Let's take an example. Suppose there are 2 points. This is point A and this is point B. Okay, and there are two friends who needs to reach point B from point A. One choose the car and one choose a shortcut path. Okay, the friend who choose the car, he has to travel along the road which is not a straight line. Okay, so he covered few distance. Say he covered 2 kilometer. He covered 2 kilometer to reach point B from A. And you were very smart. You choose a shortcut path that is a straight line between point A and point B. So the distance covered by you is the shortest distance between point A and point B. So that distance is known as displacement. Okay, it means we can say that the shortest distance or a straight line joining the initial point and final point is known as displacement, and the total path covered by a object to reach from initial point to final point is known as distance. Okay. uh, Now here we can see that the distance can never be zero, but the displacement can be zero. Now, for in which condition the distance uh, cannot be zero and displacement can be zero. Suppose you need to return back to your initial position, that is point A, and even your friend has to return back to the initial position, that is point A. Now your friend will again choose the same road, so the total distance covered by your friend will become 4 kilometer. Whereas if suppose you had covered 500 meter, okay, from one side, then the total distance covered by you would be 1 kilometer, that is 1000 uh, 1000 meter. Okay. Now according to the definition of displacement, it is the shortest distance between the initial and final point. Now because you have again reached point A, so the distance between point A and point A is nothing. It means it is zero. So in such case the displacement becomes zero when the initial point and the final point are same. Means if a body starts from a point and again reaches a same point. For example, suppose in a relay race, if a runner starts from a point, he runs along the path and again reaches the same point, then for that runner the displacement is zero, but he has covered some distance, so distance will not be zero, but the displacement can be zero. Okay, so here a few points regarding this distance and displacement. The first point is, if initial and final points are same, then the displacement will be zero. The example can be a racing track. The second point is, distance depends on path, but displacement does not. Yes, okay, displacement doesn't have to do anything with the path. It is just a straight line between the initial point and the final point. But the distance is actually the actual path covered by a body while reaching from point A to point B. Third point is, distance is always greater than or equal to the displacement. Yeah, in this example we can see that your friend covered total 2 kilometer and you covered only 500 meters. So in this example the displacement is smaller than the distance. But if suppose, if between 2 points, that is point A and between point B, the path is already a straight line, then and if a person moves from point A to point B, and suppose the straight line is of 1 kilometer, okay, then the either you calculate the displacement or distance, it is going to be 1 kilometer. So they are equal only in straight line motion. Means if the motion is in straight line without taking any kind of turn, then in such cases the distance and displacement is going to be same. Okay, so this was about the distance and displacement. Now let's move to the next topic. It is scalar and vector quantity. Okay, now scalar quantities are those quantities which has only magnitude and direction is not needed for its description. For example, temperature, we can say that yeah, the body has the temperature of a body is 36 degrees Celsius. It doesn't need any kind of direction. It needs only a magnitude. Magnitude means a given number. For example, mass, if we are saying that the mass of this object is 10 gram, so this 10 gram is magnitude. Similarly, for distance, we can say that the distance covered by a body is 2 kilometer, so that 2 kilometer is the magnitude. So such quantities which can be described only by a magnitude are known as scalar quantity. For example, if I am saying that a car is running at a speed of 80 km per hour, then this is enough. The information is enough that yeah, it is running at this much speed. So this is a scalar quantity, means speed is a scalar quantity. Now what are vector quantities? Vector quantities have both even magnitude and direction. For example, this force, displacement, velocity, these are the vector quantities. Velocity we will understand later in this chapter, and the displacement is vector quantity, whereas the distance is the scalar quantity. Okay, for example, a car is running at a speed of 80 km per hour towards north. So here we have mentioned even the magnitude and even the direction, that is towards north. So such quantities in which both the things are required, means even the magnitude and direction is needed for complete understanding of that quantity. Such quantities are known as vector quantity. Okay. Now our the last topic is motion along a straight line. It's a very important topic. Okay, now let's see the definition. When an object moves along a straight line, the motion of the object is called rectilinear motion. For example, motion of vehicle along a straight road. For example, it means that if a road is straight and a car is running on that road, then of course the car is going to follow a straight line. So such kind of motion is known as a straight line. Or we can take an example of a 100-meter race where runners run in a straight line. Okay, so these are the examples of uh, motion along a straight line. Now let us understand few things related to this motion along a straight line. Uh, let's take a reference line which has 3 points: point A, point C, and point B. Generally, point A is taken as 0 meter. Okay, this is the origin. Point C is at 3 meter from point A, and point B is at 10 meter from point A. Now, suppose the case one is, suppose the ball starts moving from point A and reaches point B. So in this case, the distance covered by the ball is 10 meter. We can see that the distance between point A and point B is 10 meter. Okay, so the distance covered is 10 meter, and also the displacement, even the displacement is equals to 10 meter, because we had discussed that when a body travels in straight line, the distance and displacements are equal. Okay, now let us move to case 2. The case 2 is, suppose the ball starts from point A, reaches B, and again it returns on the same path from point B and reaches point A. Means the ball is again reaching to point A from point B. So in this case, the distance is going to be 20 meter. Okay, 10 meter for from point A to point B, and 10 meter from point B to point A. But what about the displacement? The displacement will become 0. It will become 0. Why 0? Because here the initial point was A and even the final point is A, because the ball has again reached the point A. Let us see the third case. Here it is given that ball starts from point A, reaches point B, and then returns to point C. So here the distance covered by the ball is 10 meter, that is from A to B, plus 7 meter, that is from B to C. See, from here, from this point till point C, okay, there are 7 units. Okay, so this is the 7 meter covered by the point B. So the total distance covered by this ball is 17 meter. Okay, now let's see what is the displacement of this ball. Now the ball has reached point C. So to calculate the distance, we only need to find the distance between point A and C. And we can see that it is 3 meter. Okay, it is 3 meter. So the total distance is 10 minus 7, that is equals to 3. So this is the displacement between point A and point B. Sorry, point A and point C. Okay, here we have to see one thing, that if we will choose one direction, means whatever is going towards left, we will take it as positive, like we have taken 10 in positive, and whatever is going in right, we will take it as negative. For example, this 7 we took in negative. So this is used to find the displacement. That's it. Here are a few questions for you. Just solve these questions and check your answers.